Welcome back. In this video, I'm going to talk with you about inheritance in Solidity. The idea of inheritance is that a contract can inherit some functionalities and some variables from a previous contract. And that can be quite useful if I want to specify a few variables or functionalities which will be shared with many other contracts. And I'm going to take the source code of two previous lessons. The first one, if you remember the very first lesson, was to create a contract. We call this contract example. And we said that this example has a string, a public string. We've called it brand name. And we set it to be our brand name. So Diginomics. There we go. And in the previous lesson, we've also constructed some sort of a contract for school. We constructed a contract which allowed us to register student into our school and to collect fee for each and every student who is registered to our school. So I'm just going to paste the code from the previous lesson. If you don't remember this code, just watch the previous lesson. And you can also copy it, the source code, from the website, from the lesson website. I will make sure the code will be available there. But I will give you a very, very short reminder. We created a contract. We've called this contract example, but now I'm going to change it to be Ethereum course. And this contract contains this student struct, which we've created, a public variable for registration fee, this mapping of the array my students, which contain the list of all of my students, and it contains two functions, register and set registration fee. So let's go back to the top and let's change the name of the first contract to be owned by Diginomics. There we go. And now, because this company or any other company will probably deploy more than just one course or more than just one contract, it is quite useful to have this brand name over here to be coded or inserted into each and every other contract that it will deploy. So in order to do so, I just declare that this contract, Ethereum course, is, and now I'm going to give the name of the previous contract, which is in this case owned by Diginomics. And now this Ethereum course will inherit those functionalities, or in this case, this variable from this contract owned by Diginomics over here. And the company then can do some changes. It can change it from Ethereum course to Bitcoin course. It can change the fee from time to time. It can set Bitcoin course June and Bitcoin course August. And each and every one of those courses will have a different fee, will have a different list of students, of course. And this is quite useful actually to have your brand name hard-coded or inserted into every type of contract which you will ever deploy. But we can even make it more useful. And this is actually a good place to introduce you to the concept of ownership. So I'm going to declare an address. It's going to be a public address. And this address is going to be called owner. Now I'm going to declare a function. This function is the constructor function of this owned by Diginomics contract. So it's just going to have the same name, owned by Diginomics. It won't take any arguments, but it will do the following. It will set this owner, which I've declared over here, to be the address of the sender of the contract. So once I deploy this contract, owned by Diginomics, my address, my Ethereum address, will be automatically stored in this owner variable over here, which is a public variable, and it is an address type of variable. And this constructor will also be executed once I've deployed this contract, Bitcoin course August, for example. Once this contract is being deployed, then it will also start to deploy this owned by Diginomics. And so the address of the one who deployed the Bitcoin course August will be stored in the owner variable as defined over here. And it will be the same even if after a month I deploy a new contract for September, let's say, September. Even then, this contract will also be deployed after this constructor function has been executed, and it will also store my address into this owner variable over here. And now once I've declared this contract as an owner, and I've set this owner to be the one who deployed this contract, I can create a very powerful function, which is called kill. Or actually you can call this function whichever way you want. We can call it kill the contract. It doesn't really matter. But what this function will do, it will allow me to mute this contract. It's very important to understand that things cannot really be deleted from the blockchain, but they can be muted, which means it will no longer have any interactions. Once I have muted a contract, this contract cannot be used anymore. Any functionality that that contract might have will no longer work, cease to work, and that's it. And the way to make a contract mute or stop working is to tell him to commit suicide. Suicide. Suicide is a built-in function in Solidity. It takes one argument, and this argument is an address. In our case, it's going to be the address of the owner. I can insert whichever address I want, but I highly recommend that you will keep it as the address of the owner. And what it will do, once this contract has committed a suicide and it will be muted, then any amount of Ether which is still stored in this contract will be transferred to this address, which will be inserted over here. In our case, it will be to the address of the owner, because maybe this contract has already been active for a while and students have already used it and paid the fee in order to be registered. And maybe this contract have, I don't know, let's say 3 Ethers in it. So once I tell this contract to commit a suicide, that means that those 3 Ethers will be immediately transferred to this address over here, which is the owner address. So let's see it in action. Let's copy the code and take it to my Mist wallet. Let's go to contracts, deploy a new contract, and let's paste it over here. Now you can pick our contract. You can see I have 2 contracts which I can deploy. I can deploy owned by Diginomics, or I can deploy Bitcoin Core September. So I'm going to deploy Bitcoin Core September because once I deploy this contract, Bitcoin Core September, it will automatically inherit all the functionalities and variables which are defined in this contract, owned by Diginomics as well. So deploying this contract will basically give me those functionalities as well. Let's go back to the wallet. So I'm going to deploy Bitcoin Core September. So there's my contract. Let's set a registration fee. I want this registration fee to be 1 Ether. Remember, this is 1 followed by 18 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. This is the registration fee. Up. There you go. Let's execute it. And there we go. Now we got the registration fee to be 1 Ether. Let's register as a student. My name, Shlomi. My age is 31. I need to provide 1 Ether in order to pay for the registration fee. There we go. And let's wait for a minute. So the registration was executed. Now this contract has 1 registered student, 1 student in its my student array. And now this contract contains 1 Ether. I've paid this 1 Ether to the contract so that I will be allowed to run this register function. And so now if I use this function, kill the contract, it will commit a suicide over here, and it will send the money or the reminder of the Ether to this owner. And we can see who this owner is by looking at the contract. Remember, the owner is a public variable. So I can see that this is the owner over here. And now let's kill this contract. And we can immediately see that this one Ether will be transferred into my balance over here at the top right. From 21.58, it should be 22.58 Ether. So let's wait a second. There we go. 1 Ether was transformed from this contract into my balance. And you won't be able to use this contract anymore. This contract is muted, it won't have any working function, and that's it. The contract is basically dead. So this is it about inheritance. As you can see, it's a very powerful tool in order to build many contracts, which will share at least some part of their functionality and variables. And in the next video, I'm going to talk with you about modifiers. So I will see you then.